Hello and welcome everyone. My name is Moritz. I am one of the Dfinity community organizers, and today I am going to talk about a new project I've been working on for quite some time now, which is an implementation of Game of Life in Motoko. And the implementation, of course, is running on the internet computer. So I will start with giving you a quick demo on how to get things running first. So what we do is we head over to the repository of the Game of Life implementation and we will clone it to our machine, which just happened. And then we head into the Game of Life project. Next thing we are going to do is that we actually read the README, and you can find a small section down here which says demo. So to get this running, you need two things. The first thing is that you need to have DFX installed. The time I'm recording this video, I'm running DFX version 0.57. If you want to download the SDK, you can head over to sdk.dfinity.org, and here's a subsection with the title Get the SDK with instructions on how to install it. It's pretty straightforward. And the next thing you are going to need is npm, and same thing applies here. Just make a quick Google research on how to actually download it. Should be pretty straightforward too. So after you fulfilled the prerequisites, you can head back to the README and follow the instructions. So first thing we are going to do is we're going to execute npm install, which will install my front-end dependencies, because this project does not only have a back-end implementation for the logic, it also has some very basic front-end. And to actually serve the front-end, we are going to need some dependencies, which we are going to install now. So after we installed all the dependencies for the front end, which might take a little while depending on your machine and your internet connection, we are ready to proceed to the next step, which is to actually build the project. So before we can actually install the project, which is the third step, we will have to start our local testnet or our local replica, and we do this by running this command dfx start with the background flag. So after we started the dfx client, or the internet computer client, as it's stated here, we are going to build our project. This is a pretty simple command. We just run dfx build. This might also take some time because this also builds the front end. And if you are doing this over and over again and the only thing you change is some background code, you wouldn't really need to build a front end, which is why you could do this dfx build with the skip front end, I think it was, flag front end. Yeah, wait, let me clear this actually. Let's check. Yeah, dfx skip front end. This skips building the front end and only builds the canisters. Actually, let me switch to a new window here. Okay, so dfx build. Oh yeah, of course. I have to run this inside my project directory because the build command looks for the dfx.json file. which is this one, because this actually tells the build command some stuff on how to build things. So dfx build. Alright, now we are building the canisters, which was pretty fast, and we are going to build the front end too, which might take a little longer. Alright, so after we build the project, we are going to proceed with the last step, which is installing the canisters. Pretty straightforward too. Just enter this command, dfx canister install with the all flag, which will then install all canisters. So this now tells you your canister ID 2, which is this hex on the right side. And I actually implemented a small script which uses the correct canister ID and the correct CRC at the end, and automatically opens your browser for you with the correct canister ID and CRC concatenated to the URL. Yeah. And this is the front end. I will probably change browsers because I messed up mine with some weird preferences. So I will head over to Safari, which I normally don't use, but this one worked fine last time. And I will just copy this URL over here. And as you can see, it's the same address and the same website. So nothing really changes. Instead of that, I'm using a different browser. So now you might be wondering, what actually is Conway's Game of Life? That's a pretty good question. And if you're interested in all the nitty details, you can head over to Wikipedia and read the whole article. I will just give you a very quick overview. In Game of Life, you have a two-dimensional grid with square cells, and every cell has a state, and the two possible states are that the cell is dead or that the cell is alive. So at the beginning, you provide your game with a desired initial state of all the cells inside your grid, and you define a set of, or there's a set of rules already defined. The rules that are defined you can find on the Wikipedia page, and I will also later show the implementation of them in code. So basically, the rules are that any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell, and all other live cells die in the next generation. And similarly, all other dead cells stay dead. So, as you might have already noticed, every cell in the grid interacts with all its 8 neighbors, and to make the game progress to the next generation, you apply those rules simultaneously to all cells in the grid. And this is also called a tick, because it happens in a tick simultaneously to all cells. You apply those rules, and the outcome of this calculation is the next generation. And there's some pretty cool initial patterns you can apply that lead to stuff like this: a single Gospers glider gun, and this will just keep repeating and repeating in a loop until forever, I guess. And yeah, you can do pretty cool and funny stuff. If you're interested in those initial patterns, you can just Google them, and I'm pretty sure you will find a big amount of them. Yeah, you can try out. Alright, so after you now know what Conway's Game of Life is, let's check what we can do on the beautiful front-end implementation. A little bit of advertisement. If you are capable of doing good front-end, feel free to fork the repository or submit a pull request, or yeah, write me a message or whatever. I'm more than happy to collaborate with anyone interested in making this look prettier, because at the moment it's pretty ugly. and there are also back-end things that can be optimized. Yeah, this is by far not optimal at all, but it works. And yeah, so let's start. First of all, we are going to declare our width and height, and we do this by just entering numbers. I think I will go with 30. And by pressing populate, we will create the grid, which has 30 rows and 30 columns, and populate it with an initial pattern I specified in the backend. I can show this later on. So let's try this. And as you should be able to see, this created a transaction, and this shows us that it actually called the canister and that it actually works. So we can now try to display the current universe. I call the grid of sales universe by clicking this button. And as you can see, this is our universe. Yeah, and as you can also see, the front end is not optimal at all, because the distance between the vertical distance between the cells is bigger than the horizontal distance between the cells. This is due to the way I implemented this, and yes, feel free to tune in and make this look prettier. So this is our initial state, and if we want to see how the state or how this will look in the next generation, we can just click this render button down here, and then it will tick, so it will calculate the state for all cells simultaneously and then render it back to us. And this runs in a loop, so it will just continue to progress from generation to generation, which should then look like this. Okay, we'll probably have to reload. Oh, another nice feature, maybe this is good to show you now, is that we can, the state of this is being saved. So even if I close down Safari and I would close down my DFX, which I could probably actually do, but let me just save the link. Let's try this. So we run dfx stop, and then we run dfx start again without the background flag. So we killed the client, we killed the website. Okay, actually this one is still up, but yeah. And because of a thing called orthogonal persistence, our state is being saved, and we can actually just continue as if nothing happened. This is similar, for example, to if you have a virtual machine in your computer and you can exit it with saving the state, and then when you boot it up again, it starts where it left off, so it seems like nothing happened to it. You could compare this to this functionality. So let's head back into Safari and see if this actually even works. So same URL, and boom, here we are. And now we should even be able to retrieve the size of the universe, which initially is 0, and I set it to 30 before. So if I click the Get Universe button, there should be 30 and 30. Okay. Oh yeah, okay, nice. Took a little longer. Alright, so let's actually render our matrix. And as you can see, this is one generation, second generation, third, fourth, and so on. And it just continues to proceed to the next generations. It's actually pretty nice to watch those patterns. So at some point we either run into a loop, so the same pattern just repeats over and over, or we run into a state where all cells are dead and nothing happens anymore. So we can just wait and find out if we run into a loop or if we end up with empty cells, with dead cells. So what's important or cool here is that the development process of this was actually pretty straightforward. It was the way I would develop a normal application, for example, in, I don't know, C, Python, Java, whatever. I just used my normal IDE, which is VS Code. We have a plugin for this, a language server that helps you with errors, and we have the command line application dfx. So the whole process of developing this was pretty easy and straightforward. And actually, not only the backend but also the front end is being served from the internet computer. So this whole application runs on top of the internet computer. There's no AWS involved. There's no external database involved. It's just the code I'm going to show you later. And yeah, because this might take a long while until it actually might run into a loop, or we might not even notice that we are already in a loop, I will just stop this now, and I could proceed by clicking render again, and I can stop it again. And yeah, that's basically it. If you wanted to repopulate the universe with its initial state, you can click populate again, and when I press the render current button, it should display the initial pattern that we had before, which worked. And to debug, because actually what you see here is really are really asynchronous messages that the front end derives from the back end. So every time you have a call into the canister that alters the state, you have to actually make an asynchronous call, and this takes some time until consensus is reached, I guess. And so this is a little bit slower than just running it natively on your machine. And in the beginning, to debug, I just called into the canister, and synchronously, I didn't use the front end, I just called into it, and this function is still alive, so I could create the same pattern that I have here on my terminal. It's also pretty ugly, so if you have any tips how to make things look better, I'm very open for them. So let's try this. This one is pretty fast, so might not be that helpful. So as you can see, this now runs through, and because this is way faster, you can see a little, or you might have seen a little pattern down here. And this is actually also quite interesting, because you see that there's already a gas model implemented. We received a message saying that the canister ran out of gas, with the current gas limit being this number down here. And actually we raised this question already in our forum. If you're a developer and you are more interested in the technical things, you should join forum.dfinity.org. We'll just type this here so you can see it. And yeah, there were some answers to this. You can actually alter the gas limit for a canister. There are some tricks involved. I haven't tried it yet, but it's possible. Some other people from the community already tried it. Actually, so yeah, if you place a .toml file with those variables inside, you should be able to change it. And also, as Ori mentioned, it's now possible to set a gas limit. with the command line. Alright, enough from this. Yeah, let's head to the code, I'd say.